All right, guys, I am actually recording y'all's lesson today, so y'all will be on the video. So hopefully we'll have some real good positive interactions today. Um, I'm going to ask Connor. Connor, what did you get for cotangent of 4/5? Positive or negative? Positive, because it's in quadrant 3 where they're both negative. Good. It's square root of 3/3. Good. Good job. All right, any questions on that one? Woo-hoo. All right, so we're on the last one here, example 7. And example 7 is going to be like Thursday's quiz. Okay? I'm not going to have you sketch graphs on Thursday's quiz because it's a little bit hard for me to grade it with y'all. On the test, for sure, you'll have to sketch a graph. But I like example 7 because it brings everything that we've done in this section together, and it requires you to understand the behaviors or the characteristics of the graphs in order to answer the questions. Here's the catch. Without graphing, we're not actually going to go through and sketch the graphs and answer the questions. We're going to find the period, we're going to find the range, and then the best one of all, we're going to find the domain of each of these three, okay, or of each of these four functions. So let's start with example A. Step 1, figure out what function you're working with. Here we're working with tangent. What do we know about tangent? We know tangent has a period of pi, right? Pi by default. This is before the transformations. It has a period of pi. It has vertical asymptotes every period, right? Every cycle, every period, there's a new vertical asymptote. We also know that tangent starts at 0 with an inflection value, and its first vertical asymptote is at the first critical value, which is a half cycle away. That's the other thing for tangent you got to keep in mind. We count by half cycles. Every half cycle, there's an inflection value, vertical asymptote, inflection value, vertical asymptote. Okay, so now that we've kind of thought about tangent, it's also a monotonic increasing function. We're going to go ahead and put this one in the standard transformation form. So it makes it easier to answer questions. So we got 3 tangent of, I've got to put the negative 7 pi x first, because that's the x term, and then we get plus 6, plus 6. So I'm just going to commute the terms in the first line. And then in the second line, I'll go ahead on the inside, as we're used to doing, we will factor out the coefficient of x. And we'll have close plus 6. So we are going to be left with x minus, and remember when you factor out, you divide out. So it's going to be 6 over 7 pi. Now be careful here. Some people on the quiz didn't put that, they forgot to close that second parenthesis. If you don't close that second parenthesis, it's wrong because the 6 is technically inside when it's supposed to be outside. Now notice what we just did here. It's not pretty. It's not a pretty number, but we're moving this graph right 6 over 7 pi. Yeah? Okay, it's an ugly number, but I built it that way, so just deal with it. All right, now there's one less thing we have to do. We have a negative b value, and we don't want to leave a negative b value. So using the symmetry of the function, we either pull it out front or we forget about it. Which one do we do here? Pull it out front. Good, because tangent is an odd function. So our final line here is going to be negative 3 tangent of positive 7 pi, x minus 6 over 7 pi, close plus 6. There's the final one that we're going to be working with. All right, now we'll answer the questions. Off to the side here, it says to find the period. What's the formula for period for tangent and cotangent? Is it pi over b or 2 pi over b? It's pi over b. Okay, it's pi over b. For tangent and cotangent, it's pi. So for us, our b is 7 pi, and the pi's divide out, and we end up with a period of 1/7. I'm going to box that. I'll have you find all 3 of these things on Thursday's quiz, but that right there could be a multiple choice question on your test next week. We have one more section to cover before we test, and we'll test next week. This could be a multiple choice question. I give you the equation. I ask you for the period, 2 pi over b, boom, you're done. You wouldn't even have to put it in the standard transformation form. You could just say, oh, I know the absolute value of b is 7 pi. Okay, so you can do it quickly. The range. If I ask you for the range of tangent and cotangent, you better thank your lucky stars, right? Because you could do it with your eyes closed. What is it? All real numbers, all day long. So I will definitely ask you that on the quiz. That might be a waste of a question on a test because it's too easy, huh? Or it might make a good question from y'all's perspective. And now the domain. So I'm going to do the domain right here in the center in a different color. Here's what we have to do for the domain. We have to find the set of all x such that x is not equal to, and really what we're looking for here is where are the vertical asymptotes. That's what it comes down to. We know all those remaining four graphs in this section have vertical asymptotes. I need to know where they started, and I need to know where they ended up under the shift, and then I need to know how often they occur. That's what we're doing here, right? I need to know where they started, I need to know where they shifted, and then I need to know how often they occur. Those are the three things I need to know. So let's think about it, what tangent looks like. Now I said do this without graphing, but I mean without graphing the actual function. I'm just going to draw a little reference down here of tangent. Okay, there's tangent right there. Tangent has its first vertical asymptote at the first critical value. See that? So it doesn't start at 0. The first critical value is where tangent has its first vertical asymptote. So what do we count by for tangent and cotangent? What fraction of the period? Half periods or quarter periods? Half periods, right? So if the period is 1/7, let's come down here. What would be half the period? What's half of 1/7? 1/14. So guess where the vertical asymptote is? It's at 1/14. And then you'd have another vertical asymptote over here. It would be 1/14 to the inflection value and another 1/14 to the vertical asymptote. And then what does that mean right here? How far apart are the vertical asymptotes? What's 1/14 plus 1/14? 1/7, which is known as the what? The period. Yeah, okay. So let's go ahead. I'm gonna just write this down to help y'all keep track. The original vertical asymptote is at x equals 1/14. Okay, that's the first critical value. Okay, I'm just gonna say first critical value at 1/2 the period. I want to make notes for y'all here. Okay, now I need to know where the new vertical asymptote is. That's with the shift. Well, it's going to be the old vertical asymptote. And then if I'm shifting to the right, do I add the value or do I subtract the value? If we're shifting to the right, we're adding. So I need to add the 6/7 pi. There's the new vertical asymptote. I can put that answer right up here. So x cannot equal the old vertical asymptote plus where it's moved to, 6/7 pi. Now I have a starting vertical asymptote, because all we got to do is get to any one of them. So we'll get to that one. And then plus, switch flavors here, how often do they occur? What did we already say? How often do they occur? The vertical asymptotes are a full period, 1/7. Yeah, 1/7 n, where n is an integer. So if you want to make notes underneath, we did a half period plus the right shift plus the period n, where n is an integer. Now, you shouldn't have to memorize that. You should be able to get to that answer right there just by what we did, okay? Thinking about tangent, thinking about what we're counting by. That's what brings the whole section together. You really understand tangent that well that you can do that. If you just memorize half period, right shift, period n, then you're not really thinking. And I can't memorize it anyway, so I don't know if that's how your brain works. But that's how you get the answer. Any questions on any of that? That was for tangent. We're going to do one of each. All right, here comes part B, cotangent. Step 1, put it into standard transformation form. So we get 3 cotangent of, it's going to feel very, very similar because it actually is. I just took the same equation and changed it to cotangent. So we factor out a -7 pi again, and we get x minus 6/7 pi. What a great number. Close, close, plus 6. Now, do I bring the negative out front or leave it? Is cotangent even or odd? It's also odd, right? Let's review. There's only 2 evens where we just forget about it. Only 2. Cosine and its reciprocal secant. All the other 4 are odd. You bring it out front. So we get -3 cotangent of 7 pi, x minus 6/7 pi, close, close, plus 6. So we got an ugly right shift again, 6 over 7 pi. No big deal. All right, I'm going to come over here. Let's find the period. It's still pi over b. And for us, it's still pi over 7 pi, which, same as the previous problem, it's 1/7. I'm not copying from the previous problem. I'm actually redoing the work and comparing it to make sure it's the same. Okay, so the period is still 1/7. The range, that's still all real numbers. That's easy. So these problems really come down to the domain. The domain is the set of all x, such that x is not equal to the vertical asymptotes. So let's do what we did over there for tangent. We'll come over here on the bottom, and I'm just going to draw a regular cotangent, which, remember, cotangent actually has a vertical asymptote right away at x equals 0. So that makes this one a little bit easier. The original vertical asymptote is at x equals 0. We don't have to take a half of the period and count to the first inflection, the first critical value. It's already at 0. Okay. So where's the new vertical asymptote going to be? Well, it's going to be at the old one, 0, plus the right shift, 6 over 7 pi. And that's what goes up here. I just have to know where a new vertical asymptote is on my graph. I don't need to write the 0 anymore, so I'm just going to leave it as 6 over 7 pi. There's my vertical asymptote. And then plus, how often do they occur? Every period again. Good, which is 1/7 n, where n is an integer. So cotangent is a little bit easier than tangent for finding the domain, simply because it starts with the vertical asymptote at 0. But the thing to remember is we count by half cycles, and the vertical asymptotes occur every period. Every period. Questions on that? That's letter B. Slide on over to C. Now we're in the cosecant secant land. So remember that cosecant and secant, here's where you want to just kind of get your brain ready. These are the reciprocals of sine and cosine. So they have the same period as sine as cosine. They have the same symmetry as sine and cosine. We can kind of use sine and cosine to help us answer the questions. We just have to remember the reciprocals of zeros are vertical asymptotes or axis points. All right, let's put this one in standard transformation form. G of x equals -4 cosecant of 4 pi 7. So I got to factor 4 pi 7s out. That gives me a 77 over 4 pi. Close, close, plus 6. Now, how did I get 77 over 4 pi? Go off to the side of your math workbench and do 11. That's what we're starting with. And we're dividing it by 4 pi 7ths. So now you can do stay, change, flip. And if you multiply straight across, you get 77 over 4 pi. Okay? What you started with divided by what you're factoring out. And then don't forget to have that extra close right there. 2 open, 2 closed. All right, there's no negative to pull out here, so I think we're ready. We can go straight to the period. So for the period, what's the formula? It's cosecant. Is it 2 pi over b or pi over b? We're back to 2 pi. Yeah. So again, to reiterate, the only two that start with pi are tangent and cotangent. Those are the only two that start with pi. So we got 2 pi over b, and b is 4 pi 7ths. So if you stay, change, flip, you get 7 halves. I'm going to let y'all do that as your own. You can stay, change, flip, 2 pi times 7 over 4 pi. Simplify, the pi's divide out. 2/4 becomes a half, and you get 7 halves. Okay? So that's the length of one cycle. How many vertical asymptotes do we see per period? We see 2. Okay? That's important. So there's 2 vertical asymptotes in 7 halves, not just one. All right, so now we need to find the range. The range is going to be not all real numbers, unfortunately. But what I like to do, and let me back this up, and you don't have to do this. I like to find the range of its reciprocal function first. That's just what I do. So I'm going to go ahead and write out the range of sine. If that were sine instead of cosecant, I know that the range would be y epsilon. The low point would be d minus a. d minus a, which is 6 minus 4, that's 2. And I know the high point would be 6 plus a, d plus a, 6 plus 4, which is 10, right? And now I know, oh, if sine is everything between 2 and 10, its reciprocal cosecant is everything outside of 2 and 10. So the answer that I would post as my answer now is y epsilon, negative infinity to 2, bracket, union, bracket, 10 to infinity. Now, you don't have to write the range of sine. If you can go straight to the range of cosecant, go for it. I encourage you to do that. 6 minus 4 is 2. That's your first upper bound. 6 plus 4 is 10. That's your lower bound on the next interval. And then the domain. Yay, it's time for the domain. That's the fun one. That's the fun one. So the domain is going to be the set of all x such that x is not equal to. Got to find them vertical asymptotes. Got to find them. So let's come down here. Now, when I think of cosecant, here's what I think of. I think that cosecant came from sine. Right? Here's the graph of sine of x. Remember how we get the vertical asymptotes. We take the axis points and we turn them into vertical asymptotes. So that helps me remember that cosecant, the reciprocal of sine, has a vertical asymptote at x equals 0. So much like cotangent, cosecant is going to be the easier of the two. So the original vertical asymptote is at x equals 0. So the new vertical asymptote is going to be at x equals 0. And then if I shift it left, it's minus the amount. If I shift it right, it's plus the amount. Which direction are we going up here? We're going to the right or left? Right. So we're going right. This funky number, 77 over 4 pi. So that's my new vertical asymptote. 0 plus 77 over 4 pi. And now I can write that up here, and it's just going to be 77 over 4 pi. I don't need the 0. And then it's going to be plus how often they occur. Well, how often do the vertical asymptotes occur for cosecant and secant if there's 2 of them per period? Every half period. Yes, every half period we have a vertical asymptote. So what is half the period if the period is 7 halves? What's half of 7 halves? 7 fourths. Okay? A VA every half period. A VA every half period. Now, we still count by quarter cycles, but there's every 2 quarters we have a vertical asymptote. So I'm going to say can't be 77 over 4 pi plus multiples of the half period, which is 7n, where n is an integer. All right, so there's some things that are similar to tangent cotangent, but definitely some things that are different. If we can find those vertical asymptotes, we'll have it made. All right, questions on C? We got one more to go, folks, and it's the best one. It's the most challenging one, I think, but that makes it the most fun, and it's appropriate fitting for the end. Standard transformation form, let's do that quickly. It'll be very similar to what we just did because it's the same numbers. We get x minus 77 over 4 pi, close, close, plus 6. The only difference is it's secant now instead of cosecant. That'll make a few changes. So the period, that's still 2 pi over b. That doesn't change. So that's still 2 pi over 4 pi sevenths, which still turns into 7 halves. There's still the period. All right, the range. The range doesn't change. I'm going to try and go straight to the actual range this time instead of writing the range for cosine. So the range is going to be y epsilon negative infinity up to the low value. The low value is d minus a. 6 minus 4, which is 2. That's a bracket. Union, now I pick up at the high value, 6 plus 4, which is 10, and I go to infinity. So if you can go straight to that range, you're in good shape. All right, now the domain. Here we go. The domain is the set of all x. That wasn't a good brace. The set of all x such that x is not equal to. Got to find them VAs. All right, so here we go. Come down here. The graph of secant comes from the graph of cosine. Cosine looks like that. The vertical asymptote for secant comes from the axis point for cosine. There is your first positive axis point for cosine. There's a VA at what? What fraction of the period do we count by for cosine? Every fourth. So there's a VA at x equals 1/4 of the period. That's where the first one starts. Well, what is a fourth of 7/2? What's 7/8, right? You just multiply 7 over 2 times 1 over 4, you get 7/8. Okay? So for tangent, we had to go a half cycle over to get to the vertical asymptote. But for secant, we have to go a quarter of the cycle over to get to the vertical asymptote. That's a super important idea. Does everyone realize that? Or understand what we just did? So that is going to be what we've been calling the original vertical asymptote. It's at x equals 7/8, okay, which is a fourth of the period. Okay, now the new vertical asymptote is going to be at the old vertical asymptote plus the shift to the right, which is 77 over 4 pi. And that's what I write right here. It can't equal 7/8, a fourth of the period, plus 77 over 4 pi, the right shift. And then all we got to do is finish it off with how often do they occur? Every half period, good. So we got a fourth of the period plus the right shift, and now plus every half period. What's half the period? Still 7/4, yeah. So plus 7/4 n, where n is an integer. And if you want to finish labeling that, that's 1/2 the period n. So a fourth of the period plus the right shift plus a half the period n, and you've got yourself your domain for secant, okay? So tangent and secant, those are the two that you have to shift over to your first critical value. Tangent is a half period away. Secant is a quarter period away. Got it? Tangent, the vertical asymptotes occur every period. And cotangent, secant, cosecant, they occur every half period. If you got that kind of down, then you practice on the worksheet. You'll do fine on Thursday's quiz. And I hope you do fine on tomorrow's SAT if you're taking it. That's the notes, okay? So just to write it down, Thursday, we'll have the worksheet due at 9 a.m. And then we'll take a little quiz in class. And then we'll start the next section, which is 5.7, section 5.7, which is inverse trig functions. Inverse trig functions, okay? Any comments or questions? I know I went through that kind of fast, but I felt like y'all were getting it. All right, that's it. Congratulations, y'all are on y'all's first video. You want to say bye real quick on the count of 3? 1, 2, 3. Bye.